was like 1 over 1 something 2.
Yeah, it's very similar to this. We can break down those details later if you're interested. And then there's simple interest. And simple interest is just the amount equals the principal times 1 plus the interest rate as a decimal given each year. So these are the 3 formulas you need to know. Interestingly enough, this one's pretty simple. This one, which deals with a weird idea of something happening an infinite number of times continuously, is also very simple. It's the one that describes the most reasonable situation that's the most messed up, in my humble opinion. Okay, so these are your 3 interest equations. You're going to have to read your problems very carefully now. Are they talking about simple interest? How often is the interest being compounded? Or are they, if they use the word continuous compound interest or compounded continuously, see continuous in there, you have to use this one.
What does that stand for?
N is the number of times you're compounding the interest. So if you see quarterly, it's 4 times. If you see monthly, N is 12. If you see daily, N is 365. If you see hourly, you have to multiply 365 times 24. 8,760 hours in a year. I'm about to break into a song from Rent, so I'm going to stop now.
Really? When we were doing the calculations earlier, we didn't do N times T, did we?
I kept the first examples to just in 1 year. And then when the homework example started getting to what happens over 2 years, I would tell you to multiply it times T.
If N was like,
I'm sorry?
so if N was like month, you do 12 times how many years?
Yes.
Got it.
Yep. And you've been doing that on the last few problems correctly. Now I'm just giving you the terms for it. Okay, so that's interest rates. And I'm not going to do any examples of these now because we've already done some. There will be some more in the homework which will involve continuous. Next thing is mostly review. May I erase this? Okay.
No.
No.
You may
All right.
not.
No. And this will seem like a little different.
The draw puppy.
Draw puppy, that's okay.
How about a cat from one or the other?
Anyway, okay. Graphs of E. Okay, E is only used, well, not only. E is primarily used in examples of exponential growth and decay. Some of you did very well with this on the last test. Some of you need this opportunity to review how to graph exponential growth and decay. Remember, E is approximately what number?
2.17.
Almost.
2.17.
Andrew Jackson served how many terms?
2 terms.
What number president was he?
17.
7th, not 17. Okay, and what year was he first?
Oh, 1828.
1828. 2.71828. 17th president was after the Civil War sometime. Jackson's old Trail of Tears. Okay, E is about 2.71828. Andrew Jackson, 2 terms, 7th president, early 1800s.
You just looked
1828. Yes, I know. I was having trouble saying 18th century for some reason. Okay, so E is about that. Now, E is going to be the base of some of the graphing I'm going to ask you to do tonight. So the examples are going to be f of x equals some number a, maybe, times e raised to the x minus k plus h. So it's going to be like the graphs on the last test, but e will always be, the base will always be 2.71828. Yes? I will do an example. I'll start simple.
Act the same as they did in the other one.
K and H act exactly the same. We've used them consistently all year. And A acts the same as well. But A had really the least role in this one of the other type of functions we've looked at. Okay, so for example, let's start real simple. Y equals e to the x. Okay? Well, I'm going to make my table, which is going to be x and y. What are the three numbers I use on a very simple?
-1, 0, and 1.
-1, 0, and 1. E to the -1 is just 1 over e. Somebody with a calculator will have to tell me about what that decimal is. E is above the division sign on the TI-83. You know, 1 divided by second e. What do you get?
Hold on, I did it wrong.
It comes up in calculus a lot. You think I know this?
You failed.
I do.
0.367.
0.367, we can stop there. Okay? Anything raised to the 0 power is 1, so e to the 0 is 1. And when you put in 1, you get e to the first power, which is 2.71828, dot, dot, dot. So this graph, is this going to be growth or decay? What's the asymptote? 0. Y equals 0. If there's no h, the asymptote is the x-axis. So here's my -1. Here's my 1. Here's my 0, 1. At -1, it's about a third. At 0, it's exactly 1. And at 1, it's about 2.7. And because it's exponential growth, it looks like the plane taking off left to right instead of the plane landing. If your artwork is not great, well, that's why I'm going to ask you to label your points. But you can label them with E, so you don't have to write the decimals.
Wait, how does 1 over e equal 2.67?
E is about 2.7, so it's a little less than 3. So 1 over E is going to be close to 1/3. E, remember, E is like, we're supposed to say at the beginning, E is just a number. Behaves like any other number. It's just an ugly, never-ending decimal. All right, let's do another one here. This time, I'm just going to add an H term. Now, does H move intuitively or counterintuitively? Intuitively. So where does this thing go, up or down? Up. First thing which some people struggled with on this is this also moves the asymptote. I figured the asymptote first. It's y equals 3 because it's moved up 3. What 3 points do I like to use on this one?
1, 2,
Close. No.
-1, 0, 1.
Still -1, 0, 1. Good, Kara. You only move these points if there's a K.
Oh, okay.
Having a K moves these points. So this is going to be e to the -1 plus 3. We got to add 3 to the end. So this is going to be 3.367. This is going to be e to the 0 plus 3, which is 1 plus 3. So that's going to be 4. And I put a 1 on, and I get e to the first plus 3, which is what? 5.71828, dot, dot, dot. Add 5. Honestly, it's the Andrew Jackson thing. It sticks in my head. I still remember Mr. Natowski at Richard Montgomery in 1982 telling me that.
Wait, I don't
No
get
idea why that stuck in my head.
I don't get the 2 part of